Hello everyone, this is Adithi studying She English College of Engineering. Today I'm going to discuss some maths topics. The maths topics are as follows. The topics are angles, different types of angles, and definition of terms of an angle, projections, different types of projections and their definitions, summary on angles and projections, rotation, reflection, contraction, and expansion. Angles. In maths, angles is the fundamental concept used to measure the amount of rotation or separation between two intersecting lines or line segments. Angles are typically measured in degrees or radians, and they play a crucial role in various mathematical disciplines, including geometry, trigonometry, and calculus. Examples of angles are 30 degree, 60 degree, and 90 degree. Different types of angles and some definitions of angle. Vertex, the common endpoint where two rays or line segments meet to form an angle. Arms, the two rays or line segments extending from the vertex that define the angle. Interior of an angle, the region between the two arms of an angle. Exterior of an angle, the region outside the angle but within the plane. Degree, the most common unit of measuring angles, noted by the symbol 0. A full circle is divided into 360 degrees radian. Another unit used to measure angles, but denoted by the symbol rad. A full circle is divided into 2 pi radians, which is approximately 6.28318 radians. Right angle. An angle that measures exactly 90 degrees or pi by 2 radians. It forms a perfect L shape. Acute angle. An angle that measures less than 90 degrees or pi by 2 radians. Obtuse angle. An angle that measures more than 90 degrees but less than 180 degrees or pi radians. Straight angle. An angle that measures exactly 180 degrees or pi radians. It forms a straight angle. Reflex angle. An angle that measures more than 180 degrees but less than 360 degrees or 2 pi radians. Complementary angles. Two angles are complementary if the sum equals 90 degrees or pi by 2 radians. Supplementary angles. Two angles are supplementary if their sum equals 180 degrees or pi radians. Adjacent angles. The two angles are said to be adjacent if they have a common vertex and a common arm and do not overlap. Vertical angles. When two lines intersect, the opposite angles formed are called vertical angles. They are equal in measure. Angle bisector, a line or a ray that divides an angle into two equal parts. Understanding angles is essential in various mathematical applications, including solving geometric problems, calculating distances and heights using trigonometry, and studying functions and derivatives in calculus. Projections. In mathematics, projections refer to the process of mapping or projecting objects onto certain mathematical spaces or subspaces. The concept of projections is widely used in various branches of mathematics, including linear algebra, geometry, and vector calculus. Projections have practical applications in physics, engineering, computer graphics, and many other fields. Let's explore a few common types of projections. Vector projection. In algebra, the vector projection is a method to find the component of one vector onto another. Given two vectors A and B, the vector projection of A onto B, denoted as projection of B of A, is a vector parallel to B with a length equal to the magnitude of the projection. The formula for vector projections. Different types of projections. Orthogonal projection. And orthogonal projection is a special type of vector projection in which the projected vector is perpendicular or orthogonal to the target vector onto which the projection is being made. In this case, the vector projection simplifies to projection onto a subspace. In linear algebra, projection onto a subspace is a mapping of a vector onto a lower dimensional subspace. Given a subspace defined by a set of basis vectors, the projection of a vector onto the space is the vector that is closest to the original vector in terms of Euclidean space. It can be found using orthogonal projection techniques. Orthographic projection. Contrary to perspective projection, orthographic projection is a type of parallel projection used in computer graphics and engineering drawings. It projects 3D objects onto a 2D plane without considering the viewer's position, resulting in a flatter representation without perspective effects. These are just a few examples of how projections are used in mathematics. The concept of projections is diverse and finds its applications in numerous areas of mathematics and its applications. Summary on angles and projections. Angles. In mathematics, an angle is a measure of the amount of rotation or separation between two intersecting lines or line segments. Angles are measured in degrees or radians, and a full circle is say 60 degrees or 2 pi radians. Type of angles include right angles 90 degrees, acute angles which are less than 90 degrees, obtuse angles which are more than 90 degrees but less than 180 degrees, straight angles which are more than 180 degrees, and reflex angle which is more than 180 degrees but less than 360 degrees. Complementary angles add up to 90 degrees, while supplementary angles add up to 180 degrees. Vertical angles formed by two intersecting lines are equal in measure. Projections. Projections involve mapping or projecting objects onto mathematical spaces or subspaces. Vector projection finds the component of one vector onto another vector. Orthogonal projection is a special case of vector projection where the projected vector is perpendicular to the target vector. Orthographic projection is a parallel projection technique used in engineering drawings and computer graphics that ignores perspective effects. Both angles and projections are fundamental concepts in mathematics with wide-ranging applications. Angles play a crucial role in geometry, trigonometry, and calculus, while projections are utilized in linear algebra, computer graphics, physics, and various engineering fields. Understanding these concepts helps mathematics scientists and engineers model and solve real-world problems effectively. Rotation. Rotation is a fundamental concept in mathematics that involves the transformation of points, shapes, or objects around a fixed point known as the center of rotation. This concept is widely used in various mathematical disciplines, including geometry, linear algebra, and complex analysis. Here are some key points on rotation in maths. Center of rotation. The center of rotation is a fixed point around which the rotation occurs. All other points, shapes, or objects are rotated with respect to its center. Angle of rotation. The angle of rotation is a measure of how much a point or a shape is rotated about the center of rotation. It is usually measured in degrees or radians. Direction of rotation. The direction of rotation can be clockwise or anti-clock or counterclockwise. The convention is typically counterclockwise for positive angles and clockwise for negative angles. Properties of rotations. Rotations preserve distances between points, hence they are rigid transformations. A composition of two rotations is also a rotation. The inverse of a rotation is another rotation with the same angle but in the opposite direction. Rotations in 3D. In three-dimensional space, rotations can occur around an axis instead of a fixed point. The axis of a rotation and the angle of rotation determine the 3D rotation. Rotational symmetry in regular polygons. Regular polygons such as equilateral triangles, squares, and regular pentagons have rotational symmetry. Reflection. Reflection is another important transformation in mathematics that involves flipping or mirroring points, shapes, or objects over a line called the line of reflection or axis of reflection. This concept is widely used in geometry, linear algebra, and other mathematical areas. Here are some key points on reflection in maths. Points of properties of reflections. Reflections are rigid transformations, which means they preserve distances between points. The composition of two reflections is equivalent to single reflection over a different line. Line of reflection. The line over which the reflection occurs is called the line of reflection or axis of reflection. All points, shapes, or objects are reflected across this line. Understanding reflection in mathematics is essential for various applications, including computer graphics, architecture, crystallography, and symmetry analysis. It provides a powerful tool to describe and analyze transformations of geometric objects in both 2D and 3D spaces, and is an important concept in understanding symmetry and spatial relationships. Contraction. In mathematics, contraction refers to a specific type of transformation that involves shrinking or reducing the size of points, shapes, or objects with respect to a fixed center. Contractions are commonly used in various mathematical areas, including geometry, linear algebra, and functional analysis. Here are some key points in contraction in math. Contraction mapping. In functional analysis, a contraction mapping, also known as contractive mapping or contraction, is a function from a metric space to itself that decreases the distance between points. Properties of contraction. Contraction mapping are continuous functions. A contraction has a unique fixed point, that is, a point that remains unchanged under the contraction. Contraction in Euclidean space. In Euclidean space, a contraction refers to a transformation that reduces the distance between points and scales the space towards a fixed point called the center contraction. Contraction in geometric figures. In geometry, a contraction can refer to reducing the size of a geometric figure while preserving its shape and proportions. Understanding contractions in mathematics is essential in various areas, including study of metric spaces, functional analysis, optimization, and the convergence of iterative algorithms. Contraction mappings and their fixed points play a critical role in the analysis of stability and coverage properties of various mathematical processes and systems. Expansion. In mathematics, expansion refers to a specific type of transformation that involves increasing the size or magnifying points, shapes, or objects with respect to a fixed center. Expansions are used in various mathematical disciplines, including geometry, linear algebra, and complex analysis. Here are some key points on expansion maths. Expansion factor. The expansion factor, often denoted by the letter K, represents the scale by which the points, shapes, or objects are enlarged. If the expansion factor is greater than 1, the transformation is referred to as enlargement. If it is less than 1, it is called contraction. Expansion in probability. In probability theory, an expansion is a concept used to describe the expansion of random variables or stochastic processes in terms of a basis of functions. Scaling transformation. In coordinate geometry, an expansion is often referred to as a scaling transformation. It changes the size of an object but does not alter its shape or orientation. Point expansion in Euclidean space. In Euclidean space, an expansion refers to a transformation that increases distance between points and scales the space away from the fixed center called center of expansion. Understanding expansion in mathematics is crucial for various applications, including image processing, computer graphics, numerical methods, and the analysis of functions and transformation. Expansions allow mathematicians and scientists to study how objects and functions change when their sizes are modified, and they play a significant role in structures and their transformations. Thank you.